So, just having an interest there, I was moving to the agenda for today. I'll just do a brief introduction as to what the event is. There'll be a background dialogue by Cruz, who's going to introduce, I guess, the background to the work that we've done. We'll then hand over to Simon Scarborough of Western Power Distribution, who'll go through the phase 1 and phase 2 changes that Simon was leading on. Depending on what time that wraps up, we'll look at lunch. We're a little bit early. We could either take the time to do some Q&A, or we could get on to phase 3 presentation by Cruz. So Cruz Ficemi of National Grid will go through the phase 3 flow. Cruz is finished going through that. We'll probably open up the floor for a Q&A for members to ask any issues that they're still concerned about, and then we'll close after the Q&A. At this stage, I think 4 p.m. is probably being conservative. I think we should be out of here much sooner than that, but we'll see how we get through the agenda. Q&A will be open through each presentation, but if we can leave the more complicated questions for, I guess, when we've gone through the work, then that will probably help with the flow of the presentations. And there's a few slides to get through, but it shouldn't be bad. So here's essentially what the consultation summary. So essentially, we're seeking the views from stakeholders on the proposed modification to Engineering Recommendation G5. Issue 5, as I referred to earlier, constitutes a full technical revision to Issue 4, which was previously published in 2005. It's been extended, amongst other things, to cover assessment for concurrent connections. The modification has been prepared under the authority of the Distribution Code Review Panel, being that Engineering Recommendation G5 is a qualifying standard and a license standard under the Distribution Code. The ENG was prepared in a joint grid code, decode working group, so there will likely be some changes to the grid code as well. The grid code will be set to run their own public consultation once they get a full briefing of the change. So I think that summarizes it. With that, I'll hand over to Farouj Hussain for running through the background.
Over how people can comment on the standard in this.
Yeah, so when we wrap up all the things. Thank you.
Good morning. I'm Farouj Hussain, National Grid. I work in power quality and modeling team on TU side of National Grid. This section, I give you a review of general section of the document. Simon then takes over to go through specialized section related to voltages below 53 kV, stage 1 and stage 2. And in the afternoon, I go through stage 3. Just to give a short count, G5 won until 15 years ago, 20 years ago as G53. It was famous. Perhaps it was the first in the world dealing harmonics, citizen for other institutions and organizations to come up with their own harmonic standards. Then it was revised during 90s. It was in use throughout the 80s. When Europe was built, I remember I used G53 for assessment. And it was used for selling ADC to France. 90s, it was that we need to review that. Things are changing. G4 was produced, G53, and then again there were some condition G54 was reviewed 2000s, and then 2005 new version of G54-1 produced. Again, things changed in the network, and again, we felt that we need to review this. Proposal put forward was agreed, and 2010, the group was set up to look at this. It was published in 2015. It was a working draft. It was just a draft circulated in a very limited number of people. About 100 comments were received. If the people received it was limited, but the draft was different enough for people to comment on it. So based on comments and views of different stakeholders, a new group was set up in 2015, members, and then the structure of the working group, which is a large working group, in the sector or part of this working group, and from wind farm to NOs and TOs. And the subgroups were formed within the working group to deal with the specific area. The original terms of reference that was produced back in 2010 was the basis of the work. And most of these items in terms of reference actually came about from the actual application of the document in the field, where the shortcomings of G54-1 was noticed, and at least in actual we were against the wall. We didn't know what to do with all the changes occurring in the network. So, and I'm sure that was the same for DNOs. A major item under the terms of reference we specifically looked at, and sub-working groups assigned the task of looking at these specific items. What was possible alignment of G54-1 with the standards? To review standards in IEC, IEEE, and C, we can align them. Responsibilities, connection, assessment, deliverables. Who should do what? Responsibility of ability, what is the responsibility of connectivities? And very clear in G4-1. Data exchange was a big issue. When during the project they should be exchanged, and what data should be exchanged. Allocation of rights, that's again a big issue, because back in the 80s, where we had very few or polluting action in the network, it was easy to deal with odd ones, because few. But nowadays, even transmission level, we get all polluting loads, from small size battery to HVDC 2000 MV8 HVDC. D is the same. There's new technology coming in, IGBT-based converter. Things changed. And therefore, how you allocate headroom in network to these connectees was a big issue. Connections electrically closed. When you get a large number of connection applications, then if closed, how do you deal with them? That again was another issue. Sound measurement, how do you do it, and what standard do you use? Need for management of harmonics above 50th was big issues because, as I said, we're now getting connectees with IGBT-based technology, which emit, according to supply says, they emit harmonics above 50th. Working group and IEC, looking at this, so, we've been trying to manage harmonics above 50th since 2010, but there was no basis for us doing that. A legal basis. That's not quite right. This is in the grid code. So we use that to impose condition on connectees. But there was no guidance. That's a better phrase for it. And harmonics in G54-form was very abstract. So we thought we need to look at that and see what happens because, again, changing technologies. Subgroups which were formed, stage 1 and stage 2 subgroup, stage 3 subgroup, condition of above 50th. So we gave that task to a subgroup to specifically look at that. Resonant plant. Resonant plant is, I'm sure you've heard about at MV and LV, people's capacitor damaged because of harmonics. So we thought because there was no guidance in G54, perhaps we need to put something there so that they can be looked at and assessed before they're connected. We had a larger subgroup and a smaller subgroup depending on the cost. So the thing we looked at, as I said, was responsibilities and the background levels. So N there stands for network operator, whatever you want to look at it. Instead of calling the network owner or operator, we just decided to call it network. That's abbreviation for
NO.
NO, me, both of them. Yeah. That's confusing, Phil. I don't want to get into. So, a new document and responsibility of managing harmonics to NO. NO is responsible body that facilitates the connection. They may choose to give it to the connectee and ask connectee to do it for them or to a third party to do it for them, but ultimately NO. When it comes to background, one of the issues we had involved was some of nodes network the harmonic levels are approaching the planning level in G54. What to do with them? Some of them actually exceeding planning level and compatibility level. So what do we do with them? We put a guideline within G55. Whether to G55, I'm the draft which has been published is issue 5. So, normally, in most cases, high levels, different nodes in the system are below plan. So, when you're assessing connection, you're working with the difference between the actual you measure and the planning level. That's what we call headroom. There are cases where the harmonic levels may be above planning level, but below compatibility level. Because if you look at the planning and compatibility levels in G55, if for some harmonic and compatibility levels are different. There is a reason for that. So in that case, if the measured background is above planning level, NO, according to this document, so this is permitted to consider compatibility level for the work. They choose to define a new planning level between planning level, actual planning level in the document and the compatibility level. So that is the headroom. But there are cases also that the background exceeds compatibility level. Then facilitating the connection is responsible to mitigate that condition. Because according to this, and DCode and the G-code, 95 percentile, 90% of time, and in some interpretation, location can be above planning level or compatibility. Therefore, NO is able to mitigate that. Assessment of that particular connection in hand, they have to consider, according to the guidance in this domain, they have to consider compatibility of planning level as the background. There is no harmonic headroom available for this connection. The harmonic headroom is 0. All these planning level or assumed background equal to compatibility level should affect the TE. It has to be below the level in tables, in plan tables. Any questions so far? They looked at the voltage levels, and there were discussions as to whether we need to adopt the IEC voltage levels or voltage level in use in UK. At the end, the consensus was to go with the voltage levels that are used in UK. And this is familiar. This is a bit different because we have included 25 kV, which is traction voltage. 66 is a layer of voltage, and 66 to 230. This range includes mostly wind farm connections, and DNO and TO voltages, and this is the HV voltage level. When time do I have to finish?
Sorry, and there's no strict timeline. Just go through the background and then.
About 12 minutes on the original.
12 minutes. Yeah. Plan compatibility levels. What we did was we looked at these planning and compatibility levels in use in UK, and also in IC and IEEE, which North American use and South American use, mostly. We know that there are discrepancies. Some harmonics in one standard is higher than what we use here, or vice versa. So we say, okay, these have been in use for many years, and nothing has been reported that they're causing problem or damage to equipment. Why not using all the rest of all? And this is what we did. So the planning and compatibility levels in G55, no planning and compatibility levels are below G54-1. They're either equal or higher, which is very important when you're assessing a connection. HT, we kept it as it was in G54-1. It hasn't changed. And also, G4, when it was published, it said up to 125th harmonic. In 3 years, I don't know exactly how many years, but after so many years, the planning and compatibility tables go 50th harmonic. That's in G54-1. We've increased them to 100th harmonic. Duration, first, that wasn't in the body of G54-1. It was in ETR 122, which is a technical report you have and use in conjunction with G54. Put it into the main body. Lines with, I guess I can use this, huh? Not my finger.
Oh no, it's the microphone, sorry.
Oh, microphone.
Yeah.
So now the line with IC standard. In order to monitor compliance, 3-second and 1-minute window to the 99th percentile is recommended. That's different to normal standard compliance, which is 95 percentile. For equipment connecting at 400 volts, for ease of applying the rules, provided tables with the maximum converter or equipment that you can connect based on the reference MVA, fault MVA, which is 10 MVA for 400 kV. So if your
400 volts.
Simon is going to go through.
You said 400 kV. I said 400 volts.
Oh, sorry. 400 volts. Simon to elaborate more in detail on this, but we provided tables with the reference fault MVA of 10 MVA for 400 volts, and you scale it as your fault level change. And for 5 kV, which is next voltage level, we provided table for ease of really applying the rules.
Bruce, is there any reason why you went from the 95th percentile values to the 99th percentile? Is there any background behind why that changed?
Yeah, but this is only for short burst equipment.
Right.
Most
okay.
stars.
Yep.
Yeah. Without adopted 95 percentile for general compliance assessment.
Right, yep, okay.
Now, I don't want to get detailed because of time, but in Q&A, obviously this means you need to have different equipment to do this and all that. So, but we are limited in time for Harmonics. About 58 sub-working group came up with a very, really good report. Assessed all equipment, they assessed actual measurement, the information if whether these caused any problem in the wall. Yes, the cases where harmonics above 50 actually caused the PV to trip in UK. It's a very good report, and I think because it's part of the working group, it's public. So again, yes, we need to look at it, but with caveat. That being that it will cost a lot of money to install appropriate transducer in the network. And if you're monitoring harmonics above 50, you need equipment, money to do it, and you need transducer at voltages at the AV to 400 kV. So it is discretion of NO to say, yes, I need to assess this connection for harmonics up or low. For harmonics above 50, there are groups, as I said, in IEC and CGRE working on that. But we chose just to extend the harmonic planning levels and compatibility levels from 50th, there in G54, from 50th to 100. Harmonics and interharmonics. Measurement is very defined in G5. It's aligned with -30 and -47 for interharmonics measurements. So basically what it says, what it means here, is that you can go and buy off-the-shelf money to do this for you. They provided the table limits. Total distortion content, and subsequent ratio. Basically, this section is aligned with the voltage notch limit in G4. We adopted the same limits. We served the industry well, so we adopted the same limit for dip and oscillation, peak oscillation. What we added, which really was missing from G54, was so we looked at IEEE and adopted the IEEE with minor changes to the limit for the notch area. This is important when you're dealing with converters, inverters. That was notches. General aggregation rule. Looked at different aggregation rules in industry. Adopted IEC 6-3-6. In fact, this aggregation rule is used in many IEC recommendation, technical report, and standards. Below 0.4, below the order of 4 is 1, between 5 and 10, 1.4, and above 10 is 2. This is mostly when you are aggregating harmonic effects, harmonic voltages caused by different sources. So your connectivity and the background in the network already, you want to see the total effect. So we'll always argue that they are not added arithmetically. So aggregation rule is different to G5-4. G5-4 says you RSS this rule, which means 2, except for the highest in the background, the harmonic level in the background. These two are added arithmetically. Using RSS rule. So now in G5 we've got this rule, which is international. I think, Simon?
Yeah. Well done, 5 minutes.
5 minutes over? Or
No, answer.
Oh.
Can I just ask a question before you move off?
Sure.
I appreciate I'm about to open a can of worms, but I'm risking it. So you mentioned you were from the TO at the start. Is there any view that harmonics might be covered by SO, given that it's a whole system issue and both nodes affect each other? Should
SO.
Yeah.
SO do have asset as far as I know.
I agree. But the people who do calculations and assessments, so I'm throwing that one at you. Should the SO be involved?
I'm here from the SO. And I was involved in writing and doing it. So recently split, well, at the transmission, we've only split up today from the SO and the TO. The distribution level, they're still the same companies. So when one was there, it didn't really matter because it's the same company. Now we went to debate, and the conclusion we came to was G5 is the connection of assets, which to do with the TO. So you're connecting an asset, which is a wind farm, say, to an asset, which is a network. So if the assets are designed such that they're connected up in a way that there's no issues, then we as the issue because we're operating a system that's been designed not to have a harmonic issue. And at some future date, there becomes an issue due to some changes that maybe the SO has to start looking at this. But we haven't really thought about that to the extent it's an issue yet, but that should be outside of G5 in my mind because G is dealing with the connection of assets. But I think there's an area that we'll have to evolve and look at some point.
Okay, thanks. That's helpful. I'm glad you. I'm glad there's some recognition of that. Thanks.
There's a piece of work as well that Teresa will tell you about that the TS Innovation Project. Is that right? Do you want to talk or is that for another time?
No, that's it. I was going to mention it at the end of the day, but Ben is from SO side, as you said. We've spent a lot of time on this, and I said in his last remark, this is still a gray area. But the logic that TO is involved, that's why we called it no, because we didn't know. That, this guidance is just how to do things. It's not to say who is doing it. As long as it's a utility, the terror of it, that's fine. SO have assets, and when action is done, is applied for, if TO is going to connect somebody to the asset, is the goal. So the logic that we accepted for TO this work was based on this.
I can see that point of view, but from our point, just to put the other side of the coin, I think you know, from our relationship is with the SO. That's the counterparty to our agreements. So if we feel there's something we're not happy with, then effectively what's happening is we're going through the SO to the TO and getting comments back through the TO and SO, and it's kind of, it's just a little bit convoluted perhaps. But I see this.
No, I fully appreciate that. That's the main cause problem, because there is demand there. Your contract, legal contract with SO, holders of legal contract, that we are doing the work. And the negotiation, discussion, technical discussion can be direct, as long as SO is involved.
From the time. I'm Simon Scarborough from Western Power. In June 2016, a subgroup of the full working group was formed to look at stages 1 and 2. And I volunteered to chair the meeting, so I'm now here for because of that. In terms of the volume of assessments, in terms of numbers of assessments, most will be being done under stage 1 and 2. It's stage for the bigger stuff. Obviously, they take longer. But in terms of numbers, volume assessments is stage 1 and 2. So they will range from residential heat pump connections through to electric vehicle, multi-megawatt charging parks. And obviously, with the growth in the low carbon area, we're expecting the numbers for these assessments to increase. So in doing this revision, we've had to be mindful of the volume aspects. Distribution network operators, they have millions of low voltage connections, and each one can convert their oil fired or their gas heating to a heat pump and so on. So stages 1 and 2 have been completely written. The document is concerning stage 1 and 2. It runs to 99 pages of that. But in doing the change, then we've retained some of the principles involved. So the increasing complexity of assessment we go through is fitting with the need to get the volume of the connections aspect covered and in proportion to the risk that they present. That's retained. Use of standards to simplify the assessment method. Though the manufacturers have to comply with anyway. So that, I'll cover that later. And the idea of a maximum harmonic impedance curve that working impedance sits under as well. That's been retained. So not only have we produced the document, we've also produced additional supporting material, and 2 of these are shown here with the background to it, basically so that anyone like me reading along in the future can see what we did, and else can see that it's correct. And also then a worked examples document which runs to 141 pages, going through all the flow charts, basically all the parts of the flow chart, to prove it actually works. So is it easy to use? Okay. So in reading it, we've tried to keep a few things in mind. Looked at the standards, how they changed, and in the KIC 61000 it has changed, and then we have the technology changed, and tried to improve the processes where we could, but all the way through trying to keep this idea of the volume of connections that we're having to assess and the risk that they present in mind, so not being involved where it doesn't need to be too involved. So at the simple level, it's a three-stage process. Under the stage 1, you're looking at low voltage point of common coupling. Everyone here knows what point of common coupling is, but if they don't, it's the point as you go from the customer to the source at which another customer could connect or is connected. Stage 1 covers that. If you fail stage 1, you can go into stage 2. I'll explain that later. Stage 2 covers the case of a voltage that's below 33 kV, so typically 11 kV, but also goes up to, as Drew said, traction as well. Some network operators have 20 kV or 22 kV system as well. For now we have 6.6, so there's all sorts of things out there. So the range aspects are covered by that. And just to say what the stages are under stages 1 and 2. First two parts of stage 1 are standards-based, making use of the standards that manufacturers have to meet or can choose to meet more accurately. The second part of stage 1 is a technology-based way of doing things. Is it pulse? Is it active front end? And KVA you're trying to connect. And we end up, stage D has got a subtlety to it, where it's using the background measurement of a limiting harmonic to prove the KVA-based, technology-based assessment. And stage 2D is the final stage of assessment. So it's similar to what we had before, but it's more refined. So 4 stages in stage 1, and if you look at this, if you pass stage 1A, that's it, you're done, and so on. It's progressive. You get to stage 1D, and if you fail that, go straight into stage 2C, the final stage of assessment. We'll explain more about that. A little bit more detail. So stage is based on the standard 61003-2. That was included in the old G54. There's changes to that. Stage 1B is related to standard 61003-12. 1C is a KVA-based assessment where we cover 6 pulse, 12 pulse active front end, and 6 phase rectifiers. 1D is the variant where you're looking at the background harmonic distortion of the limiting harmonic. All the values, the inputs to these calculations, then basically move across from left to right, from 1D and 1A. You're using more information, and the level of information required is increased. If you look at 1D, 1C, and 1D, all require knowledge of the short circuit capacity of the system. And you get to the final stage, as I said, ground harmonic level of the limiting harmonic. So compared stage 1A with the old state, what was in G54, previously we had the rule that you could, if the equipment complied with 61003-2, then it could connect unconditionally up to the point where the aggregate rating was 16 amps. We reviewed this. Realised that if you have 2 kilowatt or a 3 kilowatt kettle, a washing machine which is 3 kilowatts, additional 1200 watts, you're already over the 16 amps. So that just was not workable. Where we ended up is this process, which is simply does it comply with the standard and then connect. So that's nice and easy. Again, a volume of connections allows them to progress. When the standard itself, it's classes of equipment in it. Class A covers things like heat pumps. The harmonic currents are limited up to the full harmonic, and in there for Class A are amps, and you see a graph of how they change with the harmonic order. So I believe it's based on the old dimmer switch for lighting control. So that's why it's that shape. If you look at the document itself, the scope is in this yellow box here. Electronic equipment, input less than or equal to 16 amps per phase, connected to the public voltage network, so it's not in the equipment on a private network, not subject to conditional connection, so it's actually in the wording of the document. So the intention is, in setting the limits that they've got, that is not intended to be assessed in any great way. When you look at this, this is right side. We have the ENC directive, which is a European thing, and the document is published in the official journal of the European Union. So therefore, it's a harmonized standard and allows it to be called up by manufacturers. And if they comply with that standard, then they meet the essential requirements of the ENC directive, and they can then sell it into Europe. We don't see that situation changing, but obviously, we know Brexit. We've sort of ignored that. So the scope of the document is very wide, and as you can see with the list of appliances there, we've got heat pumps, conditioning, cookers, and so on. So all sorts of things. The position we reached was that we decided that we had to rely on the standard, the limits in the standard, to allow us to progress. So in other words, if the limits aren't right, and we levels rising on the network in the future, then it's going to have to change. As they back when TVs were a problem on the old style of design of power supplies for TVs. So there we are. We did do a lot of work looking at the actual impact of connecting more and more of this equipment, and it was surprising how few items, even weak power network, could connect before hitting the limits. But some variables in there, and so when we were sort of refined our assumptions, we ended up with it might be 13, might be 20 items that could connect, and so on, without diversity and things like this. So at the end of the day, we decided that we'd live with it. And the volume of connections is so high that you can do nothing but that. But there is a word of caution. If a manufacturer were to take their 20 amp system and split it into two parts, 10 amps each, and do within the scope of the standard, 61,003, and they could then comply with those. Did that, then they would actually get a higher emission allowable if they're into the standard that relates to a 20 amp system. So they are sort of avoiding this. Avoiding any rules that we would put in place relating to the 61,312 standard, which is where it would fall. This second green box is just saying that we interpret the directive requiring all components designed to form a system be assessed together. We took that to the IEC committee that managed this document and put it to them. So they made the point about the difference between IEC directive, which is a European thing, so EN standards, and IEC standards, so they didn't really accept it, but there's some wording in the document about this, the idea that you should test the system as a whole, where it's going to be used in that format. Seems reasonable to me. Now, on A, so now we move on to B. The old document referred to -3-4 standard was a technical report using the more modern -3-12. What we do is we take the statements that manufacturers make and standard and use that rather than having to ask them for what's harmonic emissions and so on. So we're taking data they have to produce anyway. That's the idea. And I progress on. based on high-powered domestic products and some industrial will fall in the scope of this document. There are 15 amps and up to 75 amps in that range. More EV chargers can fall into this range as well. So in this flow chart, you have a limit which is basically saying, is the equipment up less than 75 amps? Does it qualify to be treated under this standard? Then the process splits into two parts, array parts there, stage 1B1, stage 1B2. In simple terms, stage 1 covers equipment where they can simply say, this equipment complies with 61312. Stage 2 is a more complicated case where at least one item is subject to a required fault level being met. Of the exact statements that they have to make on the next slide. So they have to make one of the statements under this standard, and in the other one, they actually have to say what the fault level to connect the equipment is, which both of these to simplify the design process. Someone who's familiar with this standard, and there may not be, I don't know who's this exactly, but basically it has some tables of limits, and if you look at this, the column called minimum RSCE is the RSCE is a ratio of short circuit fault level to the rating of the equipment, so a measure of the strength of the network. And this row, RSCE of 33, up to a voltage change of 3%. If you went no load to full load, if you had a system that was that strong, you'd have a 3% change in voltage. Relevant to the flicker and P28 document. In the UK, a lot of networks are designed with a 6% drop for a normal load, so that would be an RSC of 16.7. Weaker network. See, our networks are weaker than that's assuming. So that's one aspect. And if we look at that row in particular, and when the manufacturer complies with these limits, so look, we've got the fifth harmonic at 10.7%, meets each of these limits, they can say it complies with 61312. If they exceed any of the limits, there's the other part of the tables. I'll go on to that. Where do these limits come from? What do these limits mean? Well, the 10.7% is actually derived from two things. It's the voltage, it's the current that would give you a voltage of a quarter of the compatibility level, and it's higher than it's also. Over the two values, it's the value when you look at the 61032 standard for Class B products, which are portable tools, which get 150% of the rating of the Class A products, the higher two. So in that particular case, the compatibility level gave 9.9%, but with having a factor in the portable tool aspect, it was rounded to 10.7. So that's where that comes from. And if it fails that, you're into the second of this table, where they have to state they require a short circuit fault level. So that is done. You can see the values, take the fifth harmonic, the values are going up. Your methodology amount is going up as you go down the column. And basically the strength of the system is going up, the RC is going up. If they were to interpolate, basically they've worked out what passes. They can then state that in their literature to everyone, to say what strength the supply is required. So with this information and use this for the design. So if I show how we do that. So for the complying with 312, that's the simplest case. I have a formula. So on the right is SEQU with a subscript of M. So the first item M is 1, second item M is 2, and so on. So it's the rating of the equipment, basically. This alpha exponent, which is a summation exponent, with the basis in what Farouz went about earlier, and explain why they are around it in the table below in a minute. But taking the ratings, you're summing them, and then you're rooting them, and then you're multiplying by a factor. So if you sum to 1, the table below, and we say what we say is ISCC, which is service current capacity, less than 100 amps. That would be whole current metered equipment for a DNO. Then the multiplier is 29.05. That's lower than 33 used in the other document I just talked about. So, so it's actually less conservative in that assumption. And then you see all of these numbers are less than 33, indeed. And the got to that is by analysing it in a more fuller way, taking account of THDI at X2R ratios, skin effect, and so on, which I'll come on to in a minute. This, I don't want to take the sleep, but this is the basis. This is in the background document. You can have a look at that at your leisure. The key thing is you've got the harmonic emission in the minute here. This is to do with skin effect and D's in here, X2R ratio. This value here is really what you use for your voltage, how much voltage you're going to allow them to produce. So this is global harmonic low voltage value, how much you can produce, and it's a modified version of what we derive. On the wall is the global value, so derived from the planning level at low voltage, less the transferred value from high voltage. That's what you're left with to use, and then we've modified it slightly, as is detailed in the background document in one of the answers to that. So to explain that. The reason we have these exponents the way they are, it looks a bit back and forward, because fitting harmonic turns to be the 12th harmonic, in this case the 6th, and then the 3rd. So from what operator you normally expect in the graph that you showed earlier. And the number of items here. So if you stay under 5 items, then you need a summation exponent to. The result is these numbers here, which are then the multipliers used in the formula that I showed you. So that's 1B1. The next 1B is for the case of equipment where they actually state the fault level is required. In this case, what we're doing is split it into two things. You've got treatment of where they've required a fault level. That's on the right side of the equation. And you've got the one where they're saying it just complies with 312 on the left. So rather than using the more complicated formula we had with the F factor in 1B1, we've actually just 33 times. The fault level aspect is much bigger on the right-hand term, then it tends to dominate anyway, so it doesn't matter. What you're doing is you're adding the fault levels required together, ultimately, if you've got multiple items. That's what you're doing. The back is here, it's all written up in the background document, and it's basically, you get the required fault level from this relation. So that's stage 1 covered. 1D. Now this one will be familiar to you who are familiar with G54 in a lot of respects. This is the technology-based and rating-based aspect. But just carry on and avoid the words, stick to the pictures. Makes it a bit clearer. So the table 6 from G541 is shown there. 6 pulse, 12 pulse, and regulators, and this is low voltage. So you could connect 12 VA of 6 pulse converter on a, missing there is the basis, on a 10 MVA basis. And the new figures from using a revised emission profile different summation exponents and planning level, all these aspects. And TDI is included as well, 22 kVA, so the number has gone up significantly. For the pulse, it's gone from 50 to 77. Which is active in feed converters, so that shows with modulated converters, 92 kVA. And we've also got a single-phase rectifier case shown as well. The fault level, the reference fault level for that is only 2 MVA. What it's saying is you can have, if you have a fault level of 10 MVA, you can have 22 kVA. If you have a fault level of 20 MVA, you can have 44 kVA, and so on. What's there is the thyristor. It was not thought we had enough of those going forward to actually warrant bringing it through. But if there are concerns of the consultation, then that can be resurrected. See how that goes. The flowcharts are shown here. The way this is split is 1C1, first column, is to do with a single technology type. You've got 6 pulse or 12 pulse or, whereas the 1C2 covers the specific case of 6 pulse and active front end. It was possible to do that because the limiting harmonic was the same harmonic order. So the formula that we have, so it's just a simple case of scaling the values. In the right hand, the bracketed part, you put in the, in this case, it was supposed you put 22 kVA. At the bottom, you put 10 MVA, and you put your actual fault level on the network, and you would scale up or down. So that's actually the same as you did in G541. What's changed is you've now got active front end in there, and the numbers have changed. For those who understand that concept of RCE, where we had 33, if you would these by dividing 10 MVA by 22 kVA, the RCE, or the value that gives you, is 460. So a lot stronger system you require for this. It's a dual load, effectively. And then active front end, the value is 52. 12 pulse is 130. Rectifier is 270. So those types of equipment assessed under this stage are going to require a stronger supply than if it's assessed under 1B. The way it's been derived, you might say, well, where does that come from? The assumed emission profile on the top left. You've got emission, which is used, and the key thing here is THD now in there. It wasn't in old calculations. In factor is taken account of as well. To our ratio is in there. The key thing is that quarter factor. So what we're saying here is we're allowing, we've got 25% of the planning level left to use up. That's the first point. And we're now saying we're going to divide that by 4. So this item is going to get 1/4 of that. The other background to that is it's assuming 5 items with a coincidence of 0.9. So 5 times 0.9 is 4. I put 4 in the formula. It's assuming you could connect other items to the network at this stage of assessment, if not your whole planning level at this stage. Single phase is similar. The phase, you're assuming less items, so there's a 1/2 in that equation. 1/2 was the case of mixed equipment. In this case, we're using the equipment ratings, multiplying them by the factor, which effectively gives us ratio of fault level to rating. So there's two. The value for the 6 pulse is much higher than the value for the active front end. I quoted these values a moment ago, 460 and 52. Formula, again, is written up in the background. Look at it in detail if you want. What you can see here is the 6 pulse has got this distortion, 31.4%. The active front end is much cleaner, 3.37. So 1D. So 1D is a more advanced version of 1C, where you are looking at the background voltage distortion as well. It'd be easy just to go straight on, avoid the words. Flow chart, you can't see it all there, but it is. But basically, there's branches looking at the different technology types. Each one is represented. And we just look at what an extract of one of those. Again, you can't see the top on the screen there. So you've got, is it 6 pulse or active front end converter? Then it's the limiting harmonic is the that's what we've worked out in terms of manipulation. Then we have an input of the background voltage distortion for the fifth. So the DO is then measuring the background distortion at the point of coupling, or as much as they can get. Then we have a calculation of the headroom, so what's left for headroom earlier, and calculating a permitted rating of equipment you can connect. So if we go on to the next slide. The headroom is not done with exponent in this case. It's a crude version. It's using 1.4. It's using a summation exponent of 1. So it's saying the headroom is simply the planning law minus the planning. And then that goes into the region at the bottom there as the headroom. So what basically means, if you had at the planning level left, then your permitted equipment size would double. Yeah, that's what that means. 1D2. This comes from 1C2. So this is where you have the mixture of equipment. So the equation for that is this one. And then again, you're scaling for headroom. So it's the same idea. Because we've got minimum fault level, and when you have 50% of the planning level left, the number on the bottom gets bigger, and you get the fault level required is then halved. That's actually called the full stage 1. The key point here, for those of you familiar with G541, is missing, really. There's no table 7. So table 7 was a harmonics and permitted currents. So the argument went like this. The people on the working group who were manufacturers saying customers are quoting the table in G541, table 7, as absolute limits to be met in their contract. This was causing them grief, because what we're supposed to do is scale it to fault level. So if you have a different fault level on the actual network, you were not getting what you should. So they argued strongly that it should be taken down. But DNOs still want to be able to have values that they can readily reckon, and others as well. So the way around this, we found, was to put a clause in to stage 2C, said rapid assessments, but first of all, to assume that the background harmonic distortion does not exceed 75% of the planning level, subject to the agreement of the relevant network owner. So, in the graph here, the red or orange values are the old table 7 values in current. The green one, the second one, with grey on there, grey, are the values of table 7 if you just took account of the new exponent, 0.4 for the fifth, so the fifth has gone up, new planning levels. And third column, third values in blue, are if you put it into stage 2C and you work out, well, if I sat at 75% of the planning level, what current would it take to get me up to the planning level? And you can see that the fifth is then higher, the seventh is slightly lower, the 11th is higher, the 13th is higher. So this was a way of trying to meet both requirements taking it out, it couldn't be misquoted, that's giving it as a way of being done so that it could be used as a way of assessing things quickly. So that might be of interest to D&O people here in particular, or us. Right, that gets me to stage 2. Stage 2, high voltage point of common coupling, I would describe it in the old terms. It goes up to less than 33 kV. LV, you have the case of those failed stage 1 come in here. So there, stage 2C. So I should come in because your point of common coupling is at a higher voltage. It's a 3-stage process, 2A, 2B, 2C. So if we hit stage 2 inputs, the same idea of the information required is increasing as you go through the stages. The stage 2C there, you've got the harmonic currents actually being used. It's actually using the emissions that are stated for the product. Summarize it, but basically it splits into 2 parts, the 2A, 2A1 and 2A2. So this just mirrors what we had for stage 1C. Rather than go into all that detail, just go ahead a little. You'll see what I mean. This was old G54, this was called table 10 at the top. The old were on a 100 MVA basis. The news are on a 60 MVA basis, and that's because it was thought that 100 was just too high. A lot of networks were never going to be at 100. A lot of networks are more like 50 MVA as a fault level basis. So we went for 60. To convert the old values to the new, you have to check the basis of them, and that's what that middle line is. So pulse was 130 on a 100 MVA basis. That becomes 70 on a 60 MVA basis, and that compares with 76 in the new values. 12 pulse converts to 150, and that compares with 287, so that's a bit higher. And now you've got active front-end converters in there as well, but you've lost the regulator part, the 3-phase AC regulator part. Formula is basically the same as we had for 1C, but instead the figure on the bottom now is 60 MVA because it's on that basis. So you can happily skip over that. The formula to derive the value is different. Actually, that 1/2 factor is reflecting that you've got less equipment connecting at higher voltage. That's why that's there. Stage 2 is set to 1C2. So again, it's a case of multiplies applied to the rating of the equipment that's been summated, and that gives you the required fault level which you designed to. Background is still as complicated as it was. Stage 2D. Stage 2D mirrors stage 1D. So again, I can sort of take you there. Process. So again, we end up with the headroom calculation again, and it goes to formula again as before. B2, which is mirrors stage 1D2. Again, got a formula with headroom in it, and it's scaling with the headroom. Fine. We get to stage E. So this is like we had before, but there's important changes, allowing PHDI to be included, and that changes the calculations to your advantage. It allows for skin effect, which is useful. and the assessment is not just the fifth harmonic and the PhD. It is all harmonic orders because they have planning levels for every one of them. So that makes sense, especially since you're already using a spreadsheet to assess PhD to derive values, so therefore it's easy to do. The issue of up to the 100th harmonic, and it's at the discretion of the network operator. The reason that is in there is because some voltage transformers at 11 kV or slightly above, you can't rely on the output of them to be accurate in the high order harmonics. So there's a discretionary aspect there. And VT's not that good. So then get to this slide. It's a bit complicated, but if down the left-hand side, you've got SSC PCC, which is the short circuit fault level at the common coupler. So that's an input, and you can know how strong the network is. That's then used to derive the harmonic impedance. That equation on the right is useful because previously what we had was K times H times Z 50 Hertz, or Z1. ER ratios are low, as they are with a low voltage networks. The formula gives you some advantage. You're not over-egging it effectively. The IH is on the left as an input, and that's used to calculate the harmonic contribution from that current. Using these two formulae here on the right, one has got current in amps and one has got current in percentage terms. If your X to R ratio is high, as it is at 11 kV, for example, then those formulae just simplify into the version that's in G541. So in that sense, nothing's changed. You've only got benefit in that respect at the low voltage. As I said, it looks at the harmonic measurement comes in, and the summation of the measured and the predicted value from the harmonic emission, you get value that you then compare with the planning level. But doing it just for the fifth and the THD, you're now doing it for all the harmonic orders. And as I said, that's because there's levels for each of those, and the spreadsheet is nice and easy to do. Which takes me to this one. For those of the sharp ones in the audience, they would have noticed that table 12 of G54 is missing, just like we lost table 7. And then, as you can see, we've covered the possibility of a quicker assessment off by allowing it to be done at the stage 2C. The background level is at 3/4 of the planning level. And the table, the values show that you've still the fifth higher, the seventh is lower, the 11th is the same, the 13th. So in this case, that's okay, I think. So to summarise this section then, stage 1 and 2, some major changes, some minor changes. 1 and 1B are standards based. D is technology based. D is technology based, but is scaling values for limiting harmonic measured value, background distortion. 2A and 2B are like 1C and 1D. 2C is a more thorough version of the old 2 final stage. So, there we are, that's my bit. Any questions? What do we do? There we are.
For anybody else question, I really want to say this. A lot really should be appreciated how much work has gone to stage 1 and 2. And by the first glance, people say it's long, but really, used refined compared to G54. I think also in say is more defined than G5.4. Because if somebody, I'm sure you suffer from the same symptoms as us. We don't have time to spend on connection applications. So we want it to be routine. And that's what makes it. People who are dealing with connection, they just follow the steps. It's a very defined version of G5.4. It really shortens the connection process.
Yeah, look, thanks for the time. It's a tough job to do it all, so thanks, really appreciate it. A couple of things, if I may, then. So obviously, you know, a requirement for you know, people to know the fault level at the point of connection. Is there any sort of intention to roll this out to kind of the DNO kind of comes back and says, okay, we'll put a connection application in and we'll feed back data kind of thing. We can't do anything until you put a connection application in, which I understand. But kind of, you know, connection application in at points the fault level may be really poor and it may be the wrong place to be put in the main. Is there any kind of thought of rolling out, you know, data what the fault level is? Across the world?
The DNOs publish information, not one after, but in the long-term development statement. That has the fault level at the source bars, down 11 kV.
Generally, it's about switching
and that's
size,
as far as it goes.
So it has the top fault level.
Yeah.
And then when we get the application, they go, well, if this transformer's out and that circuit's out and these generators are off, the minimum fault level is this, and it's a tiny fraction of what's typically in the LDS. So it's much more onerous what we'll have to design to in practice.
Well, we're not that advanced, I suppose, is the truth. You could get to the state where all your networks are fully modelled electronically. You perhaps could get to that point, but I don't think we're there yet. Let's take back and talk about with my people back at base. It's an interesting point. But they do have the tools to derive things fairly quickly. But it is a bit disjointed. In our own case, an 11 kV planner would have to ask a system design planner, what's the fault level at the bar, so on. And they build up a model each time, and then they use a program in our company called WinDebut, where they place the transformer, they place low voltage sections of cable, and count what you've got at the end. So they're having to model it on as it occurs as an inquiry basis. Obviously, we've got timescales to come back to you on. So there is how long does it take aspect of that as well. They're aware that you'll be wanting information. It may be that in the longer term, something better could be done.
Yeah, I'm just keen, from I'm sure you see from yours, you do a lot of connection applications for projects that don't go ahead, and if we screen some of those out, it would be your time spent on the ones that are going ahead, which is good for us as customers and good for you, so he's on board,
They now have to pay, don't they, to have a... So that's quite a few, I think. There's an awful lot of speculative stuff going on back along. Any other questions? Any comments from manufacturers of equipment? I don't know if I've got anyone here.
Yeah, one of the major comments for me is you've obviously brought active front ends in, which are a new technology.
Yes.
There are no other technologies that have also come in since G5.4-1, like active filters technology. And the feedback we've been given when we put this out to yourselves was that it's implicit. Well, nothing appeared very implicit to me. And some of the manufacturers that make active front-end drives, and not all manufacturers have an active front-end version. Some of the manufacturers that do have an active front-end will use it very much as a marketing point to go, now you can use active front-end to get you G5.5.
Well, if you've got active filters, presumably you are able to derive the current emissions that you have, so it can be assessed under stage 2C, and because it's a spreadsheet approach, all you need from the DO is the fault level. and the measured background. And if you're trying to do it under the quick method, you can start with by assuming that the values of distortion are 3/4 of the primary level. So that would give you the quick.
Oh, I'm heartened by the quick measures. That really is fantastic. With customers.
Yeah.
But because there's nothing written anywhere that says what you just said, you can use the L and issue an active filter and some linear 6-foot or 12-foot pipes, then I'm fearful of this marketing exercise that will be around that active front ends is the only place to go. So, because there's nothing that mentions other technologies like active filters.
I think the difficulty with active filter is to configure it as to what the current emission is going to be.
Yeah.
So I can't see how that can be done any other way than on the stage 2C, where you put the currents in. So, as I said, it's a spreadsheet. It's just a case of some calculation and out pops the answer. So, it'd be as quick as the other way. Yeah. When it comes to passive filters, that's an interest or not. Those are more difficult.
Yeah, well, I think passive filters for me is a very dubious technology for harmonic filtering. I'm sure people will disagree.
Yeah.
Just a continued mention of active front-end drawing.
Yeah.
And the marketing exercise, it really, I can envisage this being a massive marketing tool for certain companies that have an active front-end over those companies that don't.
Yeah.
And especially in some specialist variable frequency drives or variable speed drives, that will be a marketing boom to be able to put active front ends is the way to go, and you shouldn't consider anything else. Just countering that marketing tool with using a commercial advantage from a technical document.
Yeah. So, perhaps the background, the example document could have an example that was using the technology.
That would be excellent.
Yeah. And if you have a look at the worked example document and have a think about that and see
Is there a worked
is there a
example?
way?
Is there a worked example that shows an active filter or?
I can't remember exactly. I've got the thing on the PC. It's 141 pages. I didn't print it.
Yes, but no, I've seen one for
No, I
an
don't think there was. No.
If one of those could be included, that would counter this argument immediately. That'd be very helpful.
Understood. Yeah.
Is it a specific table or text you're referring to, you're concerned with?
It's the maximum levels for stage 1 and 2 as the old table 7 and table 12.
Because it doesn't say a drive with a different front end.
Yeah. It doesn't say a drive with a mitigation technique would be equal in most circumstances to an active front end. But, and as I said before, a lot of manufacturers don't have the active front end in their arm.
A lot of manufacturers that do have an active front end are also saying there's no other mention of other technologies because they have both solutions.
Okay. You could feedback.
Sorry, what was your name?
That's Calvin Allen.
Calvin Allen.
Yeah.
What company were you with?
Power quality management.
If you could make sure that you log that feedback in the DCRP consultation, their feedback will be considered by the working group and potentially addressed before the final issue of the document gets published.
So it might be that you could have something in the relevant section where the technology types are listed.
Yes.
That references that point, and then say
You could look at the clause in the document that you think is creating an unlevel playing field and suggest something that could be addressed there to maybe.
I think it can be addressed quite simply, but it gives companies a massive commercial advantage over other companies, which I can know what you want to do to protect your network. It shouldn't provide a commercial advantage to people.
okay. questions on
That said about those is rectifiers, so like a rise in the three-phase rectifiers, 12 poles, but with a Z transformer, the front end, or sort of a pseudo, so to give it a 24 poles and to have kind of possible rest of those. You start to see,
24 parts.
yeah, it's just sort of to bump it up to get their THD look,
Yes.
so that they're less polluting, but it's probably worth having something.
I agree with that as well. It's
24
6,
poles.
6 and 11, then we'll score a factor of that.
Particularly big with rail as well.
Yeah. Okay. We'll be looking, if we're going to do that, we'll need to know, understand well the emission profile.
I'll put you in contact with the manufacturer.
Yeah. So on the subgroup, just so you know, we have UB and Siemens who are on it, two major manufacturers. Both who.
Effective from
I take your point. Yes.
I have one who uses that I could give you the contact details of.
It can be worked in anyway. It's not too bad. Right. So we can shoot past these few. These are reference. And we're now on to
Bruce. Did we want?
Here's you.
Did we have a quick cover stop to get a coffee and a tea and a water, and then maybe a short break, and then we'll get started. So we'll just say tea at 12 o'clock. We'll go again.
Can you do the calculation for the diode and
Can be done. You need to- an emission profile that you have to do. Emission profiles for the others changed. You could just use the old assumption because people didn't believe them anymore. With the more modern modelling, Frank Griffiths drove this.
Well, usually we have IG based technology. They are manufacturing different things.
Yes, I understand. Yeah.
So can we put something in the appendix which refers to tech
Well,
in the tech?
we'll see what they come back with. Yeah.
Fundamentally, we're referring to new technology types. It's always the case of
Yeah,
somebody
but
mentioned
the
something else
reason
next
they're
week.
there is because they can define well.
Yes.
So in the difficulty, you haven't got that case.
No.
Yeah, that's why I suggest make it involved. Yeah.
Just a note saying if you have a different technology, you can be assessed equally in stage 1C or 2C with your current projections.
Yeah.
Because then everyone's an equal footing.
Yeah.
Just eliminating that quick assessment.
Just in there. Yeah.
My concern particularly that they're not being fairly assessed is that we doesn't say that therefore people
That's always the problem with the old one.
Just on the presentation material to sort of go through how long time and wise it would take to go through. I guess the option is to break for lunch at 12:30.
What time?
Or we could keep going through
I just need 10, 15 minutes.
15 minutes. So,
This is for this section.
okay,
For this section.
for this section, not yet, 15 minutes. And what about
10, 10.
what about phase 3?
Oh, phase 3. Four.
Okay, it's a phase.
1.5 hours.
Yeah, I like that.
Okay, so if we maybe look to
go
You did well.
I took another position. Yeah, it was in hiding. I come the kids before term winder, half 7, and they were to train from Networks. Yeah. This is one position. I thought, no, I want to kick to drive. She joined them. But at least I did that. Yeah. But decisions. Hopefully this is the end. But before this. Like, there's so many different trains, but for me, because I'm Warwick, most of the trains don't stop at Warwick. I had to go to Warwick Park and go to Leamington. But I was in early. Woke up early, did my daughter's hair. She said, Mum, we can't change. I'm lucky that I can't go and change all the clocks in the house. She always wants to tell you. You changed it.
Even though he's not read with you.
I parked in Leamington on the free parking.
I knew it all already.
Quite early. When you start which because it was cold, I'm doing massive to get that early train. Like anything bad before 8 o'clock. Yeah. I got in here about 8:30, 8:40. So I'm late to start panicking, and I start going more in direction. When you got here, well, it wasn't a decision at all, but I was worried about taking taxis and I think we've got to be working now because
Manager, which is
so
the DSO.
I had to think wasn't like an exam, I had to always get an hour early. When you've got schools off, there's not much you can do.
EREC got different.
Yeah, be quiet. Yeah. Then you take slightly early to get all the people
First,
When I was at public, so when going through different opinions, usually,
yeah, this is my first time.
I don't have to agree with you anymore. Oh no.
I get it. Anything on my way. Yeah. Definitely. Wake up. I'll be looking back. I follow the speed. I haven't got any circumstances yet, so I just want to. I often have JTMs here, so for me, you don't know which. Maybe someone's finished at 1, they finish at 4. There's no set time. So other than we try to land them. But I think what it is they say by 4. Yeah. But if you finish by 3, you want by 3. So the question of not finishing off. So hopefully not too late. All the
we have a new team.
Just move away.
I remembered you, yeah.
How are you?
Good. Good. You?
Yeah, I'm fine, thank you. Leon sent a message to me. I think he might already text you or email you. He said he will find you on next week.
I don't think I've seen a message from him about that.
Yeah. He sent me a text saying because
Or say,
what
what is this person say, what information have you got on this, or what's the background to this, or have a conversation. Now, you think, can you say, well, it's probably not my problem, Essex have thought, you know, it's completely didn't fall to the crowd. It's really bad. It's embarrassing way, isn't it?
Juggling the ball and then dropped it.
Yeah, because he told me he would be here. And I see everyone else in the team and he's not here. I don't know.
It'll take longer
And
than
thank you for letting me
And
know.
in these arguments, these responsible things that we talked
I
about,
haven't seen it.
responsible.
I was not sure. I thought maybe
maybe
something.
he just depend on my depend on the message.
sure we'll go through all the
Yeah.
Okay.
We are, with our system data.
Technical dependencies on
Something to the
message.
DSO.
Even though information I've given me one that was completely mixed. And
It is,
That's what
it's
I've
just a
given me.
different manager.
It should be right
So,
for PV, but when you have to get rid of the battery on the PV, you can't do all that.
Do they want the same
What's what
license?
I got? They under the
Yeah.
same business licenses to find yes.
Whenever I work in the team area, because I work half of the month,
I think the conversation is like and
work around the area, because it's much easier.
There'll be possibly people listening on the
And then I think I will arrive in Paddington.
Yeah,
Then
reserve the right to ask
Yeah.
questions.
And I thought,
Okay.
It's quite a long,
Yeah.
to find the right columns and stuff, and everything else that you can change.
Can't believe the microphone's still on call, and editing save it, but
Oh, okay.
there could be people dialed in if you are having confidence.
Yeah, I'll remind everyone at lunch.
so that's what you said.
I'll mention my boss then.
I'll do. Apparently the microphone is still on,
No mention
but when it gets published online, we edit it out. So you're aware in case.
We can't mention our customers.
No.
So,
Are you going to pick up every conversation?
Glad we had that conversation out
They
there.
want to have
Very lovely.
you're aware.
We are in trouble.
Actually, I forgot about it because when he put it down,
I didn't know because I came from this company, so I thought I'd ask, so like, this is
No, just have this habit of stealing company
instead of taking this.
I've never seen Harmonics and all these. How many have you got? About 2 or 3 for each?
No way, nothing.
Yeah.
Living the dream.
The office has got 19. Steven's got 16.
All right, well,
Yeah.
I've got 3 coins. Yeah.
Okay, very good.
I know that the other we had the bus,
Yeah.
and the
Range finders.
They gave me
from my own because I was so bad.
client
And he came back
around
late.
and said, oh, we don't want this, we want send THDI. And they went, oh, well, we can do let's transform it to action. And they went, that's put down, it's like, it's like 24 slots.
Yeah.
You're a
Is that? Yeah.
it's a bit less,
I like the news one at 9:40.
no,
I took the tube. Okay, I mean,
If we can all just have a seat again and
but can you choose the card?
we'll just kick off, we'll do,
So, well, who's going to prompt someone to go and say this?
excuse me, Jen.
Done. It's not
Sorry,
an
just gonna
issue.
get,
There's a contract manager who does that with us.
Yeah.
With the white mark.
so we're just going again, we'll do a quick section on resonant plant at LV up to 11 kV. So if you'll run us through that, should only take probably about 10 minutes. And we'll probably break for lunch at that stage, just so we can cover all phase 3 in one session in the afternoon. So probably about 10, quarter past 12 through to 1, we'll break for lunch, and then 1 o'clock we'll kick into the phase 3 content. I'll just hand over to Bruce.
Cheers. Thank you, Vincent. This is a new section in G5. The reason for this section is, as I mentioned earlier on, there are lots of incidents where capacitor banks at LV and 11 kMV explode because of harmonic stress. And also when people have cables or putting new cables in their installation, it may change the background profile, amplify some harmonics, reduce some others. So basically capacitors and like capacitors have impact on the background harmonic level. So we thought we need to give guidance, conservative guidance to people, and if they fail that stage, then they have to assess it and the more rigorous, like a stage 3. So it applies to cables, capacitor banks, converters with capacitive impedance, apparent capacitive impedance. And active front may behave that way. Certain frequencies, it may have negative may show negative reactance. So it's a quick and conservative assessment. The formulas in the document, very simple formulas. You plug in numbers, the fault level, and you have the fault level. It says use these parameters from the transformer supplying the load. Plug it in with your capacitor reactance or asset reactance. And if the magnification factor that you calculate is below 1.33, harmonics up to 15, and the magnification factor of 2 harmonics above 15, then you can connect. There is no need for further assessment. These factors we've come up with, assuming you have a quarter of available to you, and work out the typical fault rate, etc., and we came up with these numbers. If a condition fails these conditions, which are, as I said, the stress is the conservative, then you need to do a stage reassessment, where you need actual background, like some stages Simon was talking about. As you progress through the connection process, you need data. Here's say logic. That's basic, and that was it that kept you apart from your lunch.
Any questions on that? Right.
I'm trying to get some power factor correction in this document. When would installing power factor correction, is it when you apply for a new network, or is it significant changes, or there's obviously power factor corrections going in on a daily basis on site?
Absolutely right. So basically, this document now says, this section says, if you are putting power factor correction capacities, you need to be mindful of harmonics. That's basically what you say. And when you have the rating for capacitor bank, then you need to put it into those equations in the document. And if you came up with these numbers, or just these numbers, then you're fine. You can connect your capacitor. But if the numbers you calculate are higher than these, then you need to go to DNO and ask for more information.
Very good. That should worry a few capacitor manufacturers.
Or the users, rather.
Yeah. Basically, in power factor correction, it's sold as a energy saving device, and therefore they take the ownership of the information.
Yeah.
At what point would that detail be identified? So if you submit a and the offer comes with a 1.5 kilometres or 2 kilometres of cable. At what point will it be identified that cable could form part of the concern, if you like, for harmonic assessment?
Well,
a lot further down the process before you realise something obvious, like, oh, we've got a great big long kilometre of capacitor.
no, by the time you establish you're going to have some meters of cables, then you need to do this assessment yourself. You see, cable changes the profile of the background, or to do calculation. The factors higher than this, the factors you calculated were higher than this, you have to go back, go to the DNO and say, well, I need more data information. As you establish need cable, and you know the value of your capacitance, cable capacitance, then you need to do this assessment.
Have you had to accept a connection offer by that point? It could be in the balance between if you're told you put a connection application and you say, okay, it's going to cost this much to cable it up, accept the offer, you pay some money, and a harmonic study comes out and says, oh, no problem in your area, it's going to cost you an extra 200 grand to put mitigations in, or $500,000, or...
Yeah, but I just...
It's a bit late.
My mind is... I can tell you about state of issue at transmission, because the cost of mitigation mitigate the effect of 400 kV cable is very small compared to the cable itself, the cost of cable. I don't know, Simon, comparable. The cost of mitigation may be comparable to the whole project cost.
Never been done.
I don't know, I would at some level, often offshore farmers end up running filters for their cables as much as they require for their power electronics, if not more. But they probably a big, because they're aware of power electronics and are already thinking about filters when they come at the connection stage. Whereas I wonder what's true if somebody hasn't got the power electronics part in their network.
I think the question is, they apply for a point network, they use cable, but what is the cost of mitigation? Do mitigation first. Can they apply a cost of mitigation preventative to apply point?
I think it's also when do they identify the need for mitigation?
Well, it's if by the time you've got to where you've applied, because when you apply, you don't, there's lots to put in the harmonics, and that might not be known as part of the design anyway, and it's not until the DL gets back to you with an offer that you know some details of the connection, whether it's going to be overhead cable, if it's going to be a T, whatever it's going to be. At that point, you've had to accept the offer before it gets into the detail of the harmonics. Is there any, but anything as fundamental as something like a cable, could that be identified a bit earlier on in the process before you have to surrender cash over to a DNO?
Do a simple assess, or you've got, if you've got an assessment of what your cable length and type of cable is going to be, because if you know you've got 600 amps or 700 amps, you'll have a size, and you may roughly know what type of cable configuration, flat formation, you can probably do resonant calculation on that cable very readily, and you can understand whether it's that length brings it into the area, i.e. 50th. If it comes area, then you know you might have an issue. As soon as you see that, as soon as you do your 1 over LC calculation for the calculation for that length of cable, you know, oh, hang on a minute, I've got a resonant cable here. Yeah. And if you find that it's way up in the higher, then you can think, well, it won't be a problem. I'll wait until I get the background measurements to come back, and then decide.
So that's the benefit of having the contestable side of the design. You can worry about this. Your headache for now.
Yeah, if you know that you can have a cable with the resonance of about somewhere quite high, and you think, oh, it won't be a problem, then you go and stick a whacking rate capacitor on the front end of it, you know that you're going to bring that back in quite quickly on just looking at it, and you can say, oh, hang on a minute, I've got a resonance, actually have a resonance situation here.
The question is, a key connection or a turning connection changes that aspect of the network, the speed and source impedance. So you know that.
This is probably going to be more of a problem when you're talking about existing site and how. I mean, for me, it's if you have you normally see these power factor correction devices at the LV, and if you're connected at MV, significant voltage level, that's a power factor correction. If it's resonant at their LV, it's their problem, not necessarily the down it is. It goes through the transformers, etc., altering the impedance. So it's understanding the impact, because more power factor correction is being added to existing and older sites than actually the sites, because they're designed with better equipment, newer equipment that's more efficient than the older sites. Which is where necessarily the people you tell them and so forth, they're changing equipment.
No, they don't. And but if they did connect and something happened to their transformer, they have to blame themselves.
Yeah. That's their issue.
So just picking up on that before, so can I ask, sorry for saying that you, can I ask the distribution connection offer now with a proposed connection which has a long cable length, whatever long means in this context, are you put a caveat in that offer which says, kind of, if we find that there's an issue later, we reserve the right to hit with a cost, or are you going to cost that up before the offer comes out?
The standard connection agreements say comply with G54.
I'm just saying, if it's our cable or if it's your cable, does it make a difference?
The timescales for quoting are set that the G5 studies are not done before the quote go out. So there doesn't seem to be an opportunity to do that up front. You accept it's going to take longer to quote.
There's usually a caveat in it that says this offer is provided subject to
G54, P28, P29.
that kind of dirty phrase, subject to studies as appropriate, conducted, blah, blah, blah. And then some, if you have enough expensive connection, you might get staged payment. Or if you're a bit smaller, the DNL say, well, have it all up front, thanks very much, and we'll give you back if you don't want so far.
Yeah.
Still,
but a customer could take it on themselves to do it, I suppose.
Nice.
Committing to the money.
Is look at it, yeah. To save some headache, is there a way to move that process? How would it be? I don't know. Just to identify beyond whether a some distance away, an LV flaky weak bit of system.
You could have tables of fault levels and length of cable, perhaps, that gave you an indication of what length of matter. Possibly.
You say it's generally that 11 fault levels tend to be limited by, or tend to be quoted in terms of the section device, so the circuit breaker.
The long-term development statement tends to give maximum fault levels, which generally, if you want to avoid replace the whole bar substation of 11 kV panels, makes perfect sense. But it's the kind of low level for this is more pressing, really.
Can you apply for that? I think you can apply for that information.
Yeah,
you have to pay for it.
Okay. More information is going to come out eventually with the Open Networks projects that they're doing. This sort of information will start disseminating out. But if you're looking at trying to get a minimum 11 kV fault level, well, take out a transformer, N-1. The primaries are normally fed by 2 transformers, so you take one of those out, and there you go. But then again said, the maximum fault level has been at the top, as well as minimum fault level, because that is just understand that the LTDSs are there and you can use it. It's just how far do you want to develop it up front, etc. And you've got to use in the recognised software to model those things.
Just so on the magnification factors, I thought we did not need voltage gain across bars as a ream for stage 3 anyway, don't we? In G54. Is that staying in as a whichever assessment? Yeah. Okay.
It's only for 11 kV below.
Right. Nice. Okay. Yeah. It's in the title.
I think we'll just break for lunch now. It's about 20 past, so we'll begin again at about 1 p.m. So it's just like back of the room. I'll get that out in a moment. If you do one of these in front of you, the microphone, if you can just press the button that goes red. So those who are watching remotely, we're going to begin again at 1 p.m. and break for lunch at the moment. So if you'd like to join back then, cheers. Thank you. To begin again, so I'll hand over to Farouz to go through stage 3. Again, ask questions on the way. For more detailed questions, if we can leave them to the end. We'll then up the floor for a Q&A, just to wrap up any issues across any of the things that we've covered today. Talk about the next steps in the consultation before we wrap up. So I think Farouz said it might be sort of an hour to an hour and a half. So we'll probably at this stage be looking to wrap up around 3 o'clock. Great. And Farouz.
Thank you very much. So we get to the easy bit of G54 now, G55. Stage 3, as you notice, we have stage 1 like G54, stage 2, and then stage 3. Stage 3 assessment applies to connection at 33 kV and above. Also, those connections which failed at stage 2C in Simon's presentation, those which failed the simplified approach for resonant plants. Part of this stage 3 assessment is sublimits and impedance loci. So connectee can use it to design the system. We call this harmonic specification in the document. The features more or the same as G54. It's just the methodology may have changed. For example, similar to G541, remote nodes have to be by nodes or those nodes which are in the vicinity of the PCC where the connectee connects, to make sure that the other nodes comply with the planning levels. The limits are based on the performance. This is very different to G4. 4 was based on first come, first serve. It meant 30 years ago, 20 years ago to adopt the approach because it was simple. By first come, first serve, we mean that the first connectee gets what the headroom is. In order to do that, you need data from the connectee. Harmonic specification, you put your can limits for what is called incremental impact. Incremental impact is the harmonic change due to the emission from equipment, the new connectee equipment. So limit for effect, I explain what these are. This incremental is the same as G54. The total is not referenced explicitly G54. And that's one of the items that caused us a lot of grief testing the connection application. I think we've addressed that. So part of the is background, existing background. The connector needs all these to do that. Headroom apportionment is because with come first served, you have a view of connection application. On the queue, maybe a 10 megawatt load, and in the queue, maybe a 50 megawatt key. First serve means that you give the first one all the headroom. Therefore, a small connection gets everything available. The next one in the queue gets nothing, which is cost on them to mitigate. The other feature, a very important feature, is this methodology we've come up with, the working group have come up with, is the need information or data from connectivity. The big issue for our connections, because people wanted their limits, their harmonic specification, before even they chose the type of wind farm converter inverter, wind turbine, or HVDC technology. They need to know what limit they have so that they can use it in their assessment of choosing a technology. So, with technology, we've addressed that. This feature is different to G54. In the assessment of stage 3, we use of transfer coefficients. Coefficients is usefulness for parameter that can assess, you can use to assess impact of harmonic source at one point, the nodes in the system, other substations. Basically, it's the same as a 50 Hertz transfer coefficient. It's exactly the same. You put it at the harmonic frequency. So it's the same concept as 50 Hertz. To make it clear, when you connect a generator, at one point you want to see what sort of voltage it produces at other nodes. Voltage drop you get at or voltage rise you get at the other substations. It's the same. The only difference is that at 50 Hertz, usually connecting a load or a connection, your coefficients is around 1. Or if you consider fault, it can be very low. It can be causes voltage at other nodes to go to 0 or close to 0. Harmonic, The resonances and interaction between the line capacitance and inductances, transform inductances, and all of that, transfer coefficients may be much higher than unity. Therefore, you may have a compliant PCC, other nodes level may exceed planning level. That's why you need to look at remote. Figure here shows what I said in words in diagram. Basically, you're connecting connection there, the transfer coefficients to other nodes, which are determined from the network parameters. Tell you if you have X level here for a given harmonic, what would be the impact at other nodes? And this, in simple equation here, tells you the transfer coefficient. Ratio of some software calls it mutual, some software calls it transfer impedance or mu impedance, to the self-impedance point of connection. So basically, in order to do this, I need to tell my software, to my model, to give me the self-impedance at this point, or Thevenin equivalent at this point, transfer impedance at other nodes. And really all the software, Power Factory and other software easily give you that. So, there are two reasons why we need to include remote nodes. One is the transfer coefficients may be above, higher than unity, which means that we get amplification, or the actual background here may be very close to planning level. A little bit of impact from here may cause the level here to exceed the planning. Harmonic headroom. We've been talking since morning about harmonic headroom. Basically, harmonic headroom is what is available. Every network has got background harmonic level. And we have to comply with the planning level. The difference between these two is harmonic headroom. This is what we can use to accommodate a new connectivity. We talked about aggregation exponent this morning. For x up to 4th, we say alpha was unity, 1. If you do arithmetic sum, that we get. So this is the background. Green line is harmonic background, existing harmonic level in the network before the connection is made, new connection is made. The difference between planning and the background is the harmonic headroom. So you can use this to connect. If the harmonic you're considering is the 5th harmonic, remember from 5th to 10th, exponent was 1.4, roughly is about 75 degrees. So the assumption is that the impact from the unity and what's in the background, that is about 75 degrees. So if that, using exponent of 1.4, this is around, this is planning level, you have that much for the new connection. And you use exponent of 2, that increases a little. all these equations are in the document, so I don't spend more time on them. Basically, harmonic headroom is the difference between back at the planning level with the alpha in there. You can see that for most nodes, I have this transfer coefficients that I explained earlier on in this equation. Basically, what I'm doing here is that because assessing a connection at this point, I see what the headroom sub B is at this point, i.e., how much I can inject at point this level exceeds planning level. That is done using the transfer coefficients in this way. So basically, headroom of node N transfer to PCC. This is what it says. So once I bring all the headroom from remote nodes to the PCC, then I'll do my appointment and come up with the limits. So my limits have got several components according to G55. One is limit for incremental. That is the impact of the new connection engine PCC to nodes including PCC. Harmonic limit consists of the background and the total change of the connection. I explain more what I mean by total change. Another effect is the remote node and PCC, as I explained. The effect is defined as the harmonic level at the PCC after the new connection is made. The component within these, within total, we call it, or document calls it, limit change. And the total change that that particular connection can produce at the PCC. Total change limit includes incremental. The other components can be derived from these three, and they are necessary for compliance purposes. And later. So basically, once you have calculated the harmonic headroom at the PCC and the remote node transferred to PCC, just the portion that the smallest of those headroom. Yeah? So that's the incremental limit. You carry headroom at other nodes. Nodes you transfer them to PCC. You carry the headroom at PCC. Consider the smallest one, and then your portion. And then for total change, you take only the headroom at PCC. and you portion it with the same multiplier. By doing this, you have your limits. And you can see that you don't get any data from the customer. That based on the network only. You have or utility have data. Then for the total limit, you add the total limit change to that gives you limit total. This is directly measurable. If you connect a harmonic monitor, you can measure that. For example, you cannot measure it directly. You have to use measurement and analysis to determine how much impact customer has. And so far, well, I think that's being very clear.
Not the back.
No, that was illusion.
Very simple one. How we calculate the M, where you are like dividing the headroom? How would you
Can I answer you that on chair in the office? No, I come. Next slide comes to it. I tell you how you calculate M.
So, I mean, Simon made the comment before that you measure that directly. I think it's actually hard to measure that directly. I'm not convinced that you can. It's just because of the bandwidth of the VT. I mean, not. Well, the VT would give an accurate signal with a 100th harmonic.
Can I ask my colleague to respond to that?
So there are. I can't talk about DNO with much experience, but at action level, we've got two devices where we can measure up to 100th harmonic. A multi-fit device you can fit to a CVT, which gets up to 100th harmonic by measuring the current in the different branches and doing some clever electronics called PQ sensor. There's also an RC voltage divider, where it's got voltage divided with two RC elements with the same constant, and then they give you a high bandwidth measurement. So obviously they are not standard VTs.
Basically, we are confident that we can measure harmonics up to 100th with reasonable accuracy. In fact, with accuracy of 5% measure.
Right about DNOs.
Yeah,
Would struggle with.
This is 33 kV, isn't it?
And above. Yeah, and above.
No, 33 kV and above.
Yeah.
But also, as you go down in voltage, VTs have higher bandwidth, so you might 100th from a kind of 1 VT, but you might get up to 30th or 50th or something. Obviously, some of the upper range is hard to get, but you're not like a transition 1 VT probably gives you up to 10th or 12th harmonic or something. So, very restricted. Yeah.
Yeah, to consider very quick. When you talk about remote nodes, how to determine them? Are they ones connected directly to the PCC or is the rule?
Yeah. All these things are going to be in the ATR 122, revised ATR 122. At the moment, I think utilities have different practices. We run the model and we look at the gains, and anything above 1.5, we say gain transfer coefficient is 1.5 and above. We say that node is impacted.
And the other question, quick. This applies to individual limits only, or applies to THD as well, this approach that you're showing now?
Individual harmonics, and you can apply the same to THD.
Okay, thank you.
practice, it would be good practice to include THD.
How do you get on in the real world when you come to do like a harmonic survey? Because most of the meters won't actually go up to the 100.
Yes, there are any off-the-shelf monitor which goes up to 100, but we use monitor that in National Grid, we use monitor that goes up to 100. The utilities, that's why in this morning I said at the discussion of the utility, because all these monitor, transducer for DNO, there would be a time where things change. But the standards are coming along with the requirement of harmonics above 50.
Yeah, the manufacturers aren't coming up as fast as you seem to be coming up with this standard. You're trying to future-proof it.
Yeah.
Really aren't there.
But if we don't put it in the standard, they won't
Yes,
put it.
no, it's very
start somewhere.
And I'm sure you're very honourable. I'm always very dubious at the discretion. Those sort of wording just frighten me somewhat.
But I think the key problem we had as well, we talked about, so we can connect, we can get a wonderful monitor, but if we connect to around VT that goes up to say 30th or 20th, you know.
No, any much after 15 is very dubious from my experience.
I fully with you, because you make a connection of 33K with one DNO, require you to do above, but just next substations which belongs to another one, they may require. So yeah, but I think the consensus within the working group was that it won't be realistic to record this change immediately.
I say it definitely needs to be done, especially with resonance as well.
Yeah.
Resonance is where you wouldn't be generating any harmonic, but over age 50, you could have a resonance where that would be a problem.
Surprised. We how 25th, 26th doesn't exist. When they put this high bandwidth transducer, we are measuring harmonics at 63rd and of low magnitude, but in some places they are above 0.1%, which is our accuracy limit. So
yeah, it doesn't take much current for that to be relatively better to affect the voltage.
Exactly. So, Selma, this is the answer to you. So what is that N multiply? For voltages of 132 and below, the multiplier is 0.5. So these voltages, the user gets 50% of the available headroom, irrespective of the size of the connection. Transmission voltages, there is a apportionment curve, which take into account the connection. Here is defined in this table. One voltages of 132 up to 275. Sorry, of 132 up to 275 is 1,000. 275 is 1,500, and 400 is 2,000. Need to determine Km for a specific connection is the customer tech value or value. That's all. They're applying for 2000 VA connection. So I just put it in this equation. I Km. I go this curve, look for Km of that value, and determine M. Apply M this equation. Any question?
Can I ask a question? I kind of know the answer already, but in simple terms, what is that curve trying to achieve?
Right. You see, I think I said small connection gets all the headroom, a big one gets nothing. This way, we give this according to size of the connection. And with this is then everything to one connectivity, which might be small. So you can see the limit never gets to zero. There is always something left in the network because portioning the remaining headroom that gets to zero. You may ask for transmission voltages, why these numbers? With assessment, we looked at all connections in past 15, 20 years, up to 2022, the size of the connection we are going to have and we've had, and Km such that 75% all connections get 25% of the headroom or more. These knee points are related to the past connections data and future. One for the highest, was determined for the highest polluting load we've had, polluting connection we've had in GB network so far. 2000 years. And that's easy, so it's good. The feature of this, which was missing in G54, is the amplification effect. It's all been found, and most of HVDC transmission level, and I'm sure at 33 kV at the level, there are always piece of cable involved. So modify the harmonic profile at the point of connection. G4 didn't have explicitly anything on that. There are some references in ETR 122, but G54 brought that into main body of the document. So total effect of the connectivity includes amplification of the background. And part of the limit. Earlier on, you define two limits. So other parameters that you need to use in design or show compliance with limits can be derived from those two limits and background. For example, limit for resonant plant, I want to see whether I'm complying or not. Range, which I showed you how it is calculated, minus the incremental, how much of the limit of being given I can use for amplification of my cable, amplification of background by my cable. You can see here that I have VH incremental limit. This is the limit. The utility, when I do limits, when I do the assessment, I do this information. But customer, when they design and choose their inverter equipment, they do that. What of this is saying is that change contains the limit for incremental. But our equipment injects all the harmonics. They inject certain harmonics. The equipment is not injecting any incremental as a given harmonic. It's allowed to use all the limit change amplification. Connect puts that to 0, and limit for resonance would be the same as limit for change. It's not true the other way around. You cannot use limit allowed for amplification for incremental. And the reason for that is that limit change is calculated locally at the PCC. It does not include the effect on the remote node. So the level that is given for PCC cannot be used to inject more for it, because you don't know what happens at remote. For emission, only incremental limit has to be considered and used. The diagram shows the situation with different limits for alpha of 1. Because background, I through my apportionment process for incremental, that would be the incremental limit. Then I apply that to the local PCC headroom, and this difference between this and that would be the limit for resonant plan. This is what I can use to take into account the effect of my cable and capacitors on the background. Was missing from G5. And I put this note here, which explains what I meant, that if the customer is not use this, yeah, if injecting any harmonic at this frequency, it's this bit for amplification. It cannot use this for increment. Question? Yep.
Calculate incremental. Do you take into account the effect of the resonance, or it's only the injection from the equipment?
Effect resonance the phase resonance would be inherent in this. In resonance, the transfer coefficients would be very high.
But that between the DCC and another. But you have a resonance within the system that amplifies, not the background, but amplifies the injection from the unit, let's say from a wind turbine. Will they be taken into account in this?
It does. The volume is just based on the size of the connection and the hem available locally. If there is a resonance, then user has to make sure that it complies with this.
Okay.
The resonance locally causes compliance against this, then they have to use mitigation.
Okay. Thank you.
So you can see recap. In order for me to set limits for a new connection, to background measurements at PC and remote nodes that I identify may be impacted. I need to run a model to determine this. None of these has got anything to do with the user. In fact, I can have that stored somewhere, and as long as the system hasn't changed, I can just pick it and use it. Determine the headrooms from measure value and from transfer coefficients. Item M it only is the size of the connection. That's all. And I limit. And the document is typical. You may choose to add other limits in there. As long as you've got at least these three, you can determine resonance limit, you can determine the change limit. In addition to this, the customer, in order to check compliance against these limits, needs evidence loci. A lot of time on 7 equivalent at the PCC or of the PCC. So we still don't at the of the PCC. So it's a, in order to get with this table, you need the impedance profile, harmonic impedance of the PCC. Then the user has got all the information to check compliance. GIF didn't have explicitly didn't have any guidance on compliance. And we always go into discussion with the users, what is compliance? What do you require? We've got action on compliance now. And so the user needs to produce a compliance report, show compliance incremental limit, and with the total limit, And so, in order for the utility to check compliance, the user needs to provide the VH total, which is the total effect of the customer. It's not the same as total limit is what we produce. This is what the customer produces, choosing the equipment and design. It allows by having these compliance. I see the total effect of the customer is incremental effect. It produces through emission and also magnification in the background. And impedance is the impedance we provided of TC without the customer, and this is the impedance of the same node after the customer is connected. It shows what impact the cable and other equipment had on this impedance. This impedance at the given harmonic is raised, it means amplification. If it's less than this, it means actually the customer equipment is absorbing some harmonic. One of the issues in terms of reference that we had to look at was exchange of, as I showed this morning. In the, we reduced the reliance of setting the limits on the customer data to a minimum. So stage assessment can be done at earlier stages of the connection application. Which is a big issue for many of our customers. And I'm sure you know. So this is what I'm talking about, compliance report, has incremental effect, the equipment, and the total effect. So we can check use values, we can check compliance against the limit. This compliance report is produced after users design their network and chose their equipment. The type of cable they're going to use, what type of or inverter, converter they're going to use, what sort of emission profile they have. There is a recommendation in the document about by measurement. So it's recommended that before customer is connected, we start monitoring to get the print of the network, and during commissioning, as they switch on the equipment, we see the. So, for example, a turbine cannot be connected without a cable. So, cable is connected first. It is on for some times. When we switch, we can see if there is any change in background harmonic level. And then as they switch on equipment, we see the changes. I haven't had these cases so far. But there is a possibility that when the customer connects, they are not complying with the limits. So the reason, and these are in the document in G55. Give a hint of this arise in practice, and also sources of non-compliance. So one, the user didn't design the network properly. So for that, there might be they're not complying with the limit because the impedance data of the PC that the utility gave the customer or in the harmonic specification did not include all the operating conditions of the network. It didn't have all data of the connections preceding just this connection. Or, as you noticed, we use this aggregation of alpha 1, alpha 1.2, 1.4, alpha 2. And when customers connect, the diversity between what the customer is doing and the background may not follow that route. It hasn't happened so far, but our participant, working group participant wanted this in there. They thought was fair. Just a hint.
If you can identify risk, what would the recourse be? The design, would that mean you'd have arbitration of some sort or get an independent review? Or, I mean, you can have those, but you must have a result or have an idea of a way of resolving it. Otherwise, you could spend all the time around the table.
Assuming it's not that.
Well, based on everything that goes before it, it'd be difficult.
Right. All the connections we've assessed under existing stage 3 assessment. What is the limit? Always, nearly always, customer comes back and says, we comply with your limit at this given harmonic. What? And we have to be flexible and look at that and see if there are more limits, or look into the impedance data. And if impedance data is actually related to that harmonic, they are having a problem. Because remember, when we give impedance data to customers, we give it in the form of loci. So we run the model for several operating conditions. They are all R and X for different. And draw a line around this, and we say, this is the impedance. Impedance is going to change within this line. And usually, according to IEC, following IEC, we usually define the range of harmonics. And there is a technical reason for that. So we say this loci apply harmonic from, say, 5.5 to 7.5. Sequence of the network is going to change within this line. And they have, suppose they have problem with the fifth harmonic. When this fifth is setting, is what we are going to change. So there's always some room for flexibility. Limit, you may be strict on the limit and say, well, I've applied this, I want to be fair to all users, and the model I'm going to use, this is what G55 has suggested, or this is what I'm going to use. But with this argument that at that point, in the next few years, no one is going to connect. So I know I have some room to maneuver.
Not giving the whole of the headroom, but giving a portion of it,
Yes.
because it gives a bit of flexibility,
Better.
potential.
Connection, that wasn't defined. And we always had discussion with connectees about who is first, who is second. Why the guy is getting whole, I'm getting nothing. And questions about MODAP and all that. So, data signing the agreement is now in the document.
Sorry, can I jump in on that one? So, let me understand it before I object. So two people who apply, I first, I've got a validity period, I accepted it, but it's still within the validity period. Somebody else applies after me, accepts it straight, and has accepted while my validity period is still valid, they have me in the queue. That is. This is going to be trouble. This is going to go all over the system on that.
That's standard tech queue position rules. Queue for this.
You can't run that system. A valid offer, I believe that offer is valid.
Yeah.
You also sent me a valid offer, put caveats on it.
But the offer doesn't have the harmonic limits in it yet, generally. So you're not being around harmonic headroom at that point. I think given limits and loci when that starts applying to you, we wouldn't then retract the limits and loci we've given you.
I think if there is like connection between your offer, then
Yeah, if we knew about it at the time, so if there are two offers out that affect each other, i.e. if one person signs first, it affects the other's offer, they go through the activity process. The point being made is that we generally don't know at this stage if the harmonics are going to affect each other before you sign. So by the time you actually get these limits, you'll already be in a queue position at the time the offers were signed.
But with me, well, I had a valid offer.
So you don't have limits yet at the time you're signing your offer.
Well, did they have limits? Then you wouldn't have a problem.
If you can do it, if you can do it in 3 months, then yeah.
So many feeds in, we know we won't exceed that. Taking in fuzz and refusing people. It's a little bit more scientific, a little bit more.
We were talking about refusing people anywhere here, are we?
Well, it will if you go over the head.
But increasing people's costs, whether it's refuse them or increase their costs. Once you start playing with people answers, you're at risk of them.
But if you've got a fixed amount of limits in, you know, offer people deals and say, come on.
But it's not something we've changed. If somebody else has signed ahead of you, they are ahead of you in that tech queue, and that's the position that they are in.
Oh, we're not saying or anything. I'm saying just plan it a little bit better. Fixed amount of feed-ins, and you disappoint anybody, and it looks as though you know what you're doing. You've got a plan.
But what if they sign the offer? We have plenty of offers that go out that never get signed.
Well, the next customer comes along, will sign the offer if you have fixed feed-in frequency number. It seems just a bit willy-nilly. What comes along, the right size.
No, this is far better. This is far better than it is at the moment, because you know when you get your offer that there's headroom.
Oh, I'm not saying it's
and then you
better.
know that there will be an allowance. It's just you'll get that specified for the connection in time. so that you follows on in a role. It's just a case of the board operator assesses and says there is enough headroom for another connection or connections.
Size or
But when
and
the
then
offer
as you
goes
go
out,
through the process, your information is refined.
but at the point when the offer goes out, no harmonic assessment's been done. There's no allocation of anyone's headroom. Send that
No
process.
allocation, but you know from the Tevenin equivalent, you know that you've got headroom. Otherwise, you wouldn't be able to for the equivalent.
No, we don't. It might be no headroom anywhere, and you just connect. You need to put install mitigation. But the harmonic limits and LOPO don't tend to go out with the offer. They tend to go out when further out when we're actually close to connection. We actually have some information.
Process is not in place at the moment. We are not following it. But because simplified in terms of determining or calculating the limit, we haven't done it, but it can be during the offer period. The limit can be done enough during offer period, and actual limits can go into BCA. We haven't looked at it, but it can be done. We are doing it because the process needs data and other stuff from customer. At the moment, it does allow us to do it within 3 months of offer period. But where we don't need any data from customers, it is possible to do it. And you're right, we can plan it, do this, especially now we are putting in wide monitoring system where the background can be done quickly instead of engineers going to site. We can really do this within the offer period. But your point is different. Your is where some actually firmly signed, but someone is during that period that I'm not familiar with. Mark is more, and our guys are more familiar.
So I guess my point is, what would be a fee of making it, instead of when the connection offer is signed, it's when the connection offer is applied for? Would that be for the applicant? Because then you're not, there's a risk to my mind. Assuming he's done any harmonics work, which I think is the state at the minute, I think they're in whoever's applied for this genuinely is ahead in the queue, and as long as the offers both have the same 3-month validity period, then there's no questions of kind of moving in the queue because they happen to have signed it.
So the way we do capacity at the moment is the same, the same thing. If as I say, 2 offers go out that are based on megawatt capacity existing in a certain area, and they're both after that same capacity, they get interactive with each other. If we were in a world where harmonic studies were done during the offer period, which we're not, but okay, let's assume you're in that world where you could do it, then almost every offer in a certain area, I would presume, would probably go interactive with each other. Because as soon as the second one goes out, unless there is enough headroom for them both, well,
that's my point, Mark. On straightforward capacity, then applying somebody else applies, those offers become interactive. So I know that I'm in a queue, and I know that if I don't accept it in the interactivity period, I'm going to be allowing somebody else in ahead of me to make that decision to allow that or to get me in my pocket. I'm not getting that visibility because you're not doing the assessment during the offer process. All that happens is kind of effectively somebody is coming in and I've taken a fraction of the headroom capacity that I wasn't aware of. So it's the lack of visibility of the process, I think I'm concerned about.
Why you say there is lack of visibility? Because the information that you have access to, somebody else has access.
Yes, okay, but if they've signed an offer before I thought.
I don't think it's because we haven't done this in the offer period. I don't think it's made a material difference to your offer. We have given you 6 months.
Exactly. The reason it doesn't go interactive at the moment is that it doesn't change your offer.
Yeah, but yes, and I didn't know about it. That's the point. It's only less because I didn't know. I haven't got that information, so it's less.
But then you can go down that route for anything. I mean, you might be after 2 customers be after the same bit of land, make people interactive because they're going to affect each other on land. You know, the future things that might come along that we don't know about, we don't make people interactive about. Everybody who's in that process knows. I don't know entirely to agree with you, by the way, but in that process knows that if I take the full 3 months to sign, I take the full 3 months to sign. Somebody that signs a week after they get their offer, even if it's after me, they're ahead of me in the queue. That's just a known.
I have control over my land. You don't have control over my land. That one doesn't. That's not. You have control over. The harmonics. It's part of the network capacity. It's in your land, isn't in your hand. I'm not asking you to control land. Anyway, just thought it makes sense to make it the issue.
The other about doing harmonic studies very early in advance. Some people that sign up years or decades ahead of actually connecting.
Yeah,
we measure in background harmonics something that's not real to when that customer connects.
Absolutely see that, and I'm not. I wasn't trying to push for doing the harmonics assessment during the period.
Yeah.
I'm just looking at whether the connection offer being signed is the best date, or whether an alternative date, such as the application being made competent, for example, would allow people to compete more fair.
I think we would probably, personally, I quite strongly argue against that. I don't think you can have a position where you have a tech queue, which is, for megawatts, is based on when people sign, and for something else is based on when they apply. I think that the queue is the queue. It's when people sign, that's when we're in a contractual obligation with them, that's where they're in that queue position.
I do see that for capacity, Mark, because so many offers that aren't accepted.
And then you get
This is no different to what Mark said, and apply to all different conditions. The other point is that once the connection is made and the user is energized, it's part of the background. The whole system is operational now, it's connected to the network, it's part of the background. So what we need to do to determine their impact is just do a background measure. That's all. There are cases where fictions are very close to each other in time. That was missing from G54, and we had a lot of problems with this. Because we did what to do. And the next customer didn't know how to determine the limit for the next customer, because the first customer is not yet part of the network. They've built the limit, but they haven't built their network. In the 80s, with G54 and 20s, when G5 it was okay, because we had very few connections. Nowadays, we've got a lot of connections. We need a method to deal with them. That we call concurrent connection. This applies to situations where limits should be issued to the next user in the queue without being part of the network. There are two sections in the new document. One is the next connection apply for connection to the same point as the first one, same PC. In other cases, when it applies to a node where close, electrically close to the first PCC. These two are covered in the document, and guidance is given as to how to deal with them. Basically, when you calculate in this simple method, for the first quantity, you use those limits as the impact of deflection onto background at other nodes. So you have to modify the background you had with these limits. The new background for the second connection and the procedure is exactly the same. The modified background, then the same. Any questions?
Accuracy for something like that, obviously confidence. If you have a time to measure your predictions to see how accurate those are, and then using those predictions to form another prediction, what's your margin for error on that?
The margin.
If you had to make an offer to somebody coming along, do you make that and say to them, this is what you can do, but there's a window of uncertainty of error here because customer A hasn't connected yet and we haven't had a chance to verify our.
Well, the of errors are those which are listed. The action method may not be right. When we determine the optional condition of the network, i.e. outages, all these impact the limits we calculate. When we modify the background at different nodes by the limit I issue to the first one, the action may not follow the rule I'm using. But that's the only tool I have from international. I do hear your suggestion.
A protection for the user connecting is that we'll do a period of measurements immediately before they connect, immediately after they connect, so we can look at the impact that they're having. And so that if they become non-compliant, well, if we start exceeding, say, the total limits in their agreements, but we can see that actually if the measurement before was increased, it's probably the customer before them, protected against that in that measurement campaign. You can see that it was connected. But I think that's the way. I mean, find the customer responsible and managing that is a hard task. We sort of crossed that earlier.
So, Farouz, with that last line, are you suggesting that the other user that is connecting close to you has to provide that other customer their model of their site, etc.?
Good point.
Because
I kept quiet. Pointed this. I was waiting for questions. It's a good point. I come back to it.
Yeah.
Let me just explain one point. And
this is really above 33 kV. So above, yeah. So this is, I mean, the context we've been generally talking about is sort of transmission level. I mean, this is really going to be quite good fun at DNO level, isn't it? It's going to be a lot more connections.
Yeah,
interaction.
Well, this is where I'm getting to, because you can get security classified sites connecting at 33 kV, etc., and they want the information, rain or shine, because they have anyone knowledge of their site and operation.
well, let's keep that special case of security of the site. In a normal situation, you have an application, beginning of the queue, you issue the limit. The queue is immediately after that. So the one in the queue doesn't have any information about their design yet.
No.
But you have to issue the second one in the queue, the limit. So they get data from the first one to put it in a model and calculate transfer coefficients. That's some consensus has to be made between parties. One point which is fact is that for concurrent connection at the same point, what connectee connects does not affect the transfer coefficients. There, your model is still valid. So whatever cable or anything connects, change in impedance, a change in self-impedance would be same as percentage change in mutual. Therefore, your gain stays the same. The problem is when they are different points. To calculate the transfer coefficients from the other node to others, you need the network from the first one. That's the only situation where you get data from the first one. Loci. Therefore, there has to be a compromise connectees. This between connectees and the utility and come up with.
Could that be solved via a Taven equivalent of the first connectee site?
Sorry, say it again, Mark.
Could that be solved by the first user, network operator, doing providing a Taven equivalent of that site?
Would do, but you haven't got detail to produce the model. That's the case.
No.
That's the situation. That's what the situation is.
Yeah.
You got that they're going to work in, but you don't have their detail sufficiently to be able to have that remote model. Yeah.
In fact, this is in the document. So there must be a discussion between parties to have that situation. The only situation that needs discussion between parties is concurrent connection at different nodes. And they are each other in where the first one hasn't designed their network yet. They give you any data. Practically speaking, at distribution, I agree, because IT is very large. But at transition, cable length, cable capacity, cable type, you can come up with a typical and say, I'm using this in my model. Is that okay? But distribution, the variety is maybe.
You have a data center, you can have a wind farm, or you have a data center and a FedEx. You could have any of those combinations on a third-party network.
Going back to what I said earlier about total is the parameter that you can directly measure. Concurrent connection at the same point, you assume that the T has shows the level at total level, total limit. With the new background. Then you buy the remote headroom transferred to the PCC by the incremental issue to the first one. So it reduces. Then follow the apportionment rule. That's all you need to do. That's complicated. It's not complicated. It's just. Remember, we've issued the limit to the first connection. We've issued the total limit. We issued the incremental level. We assume the first PCC, first connection, has gone up to the total limit of the first connection. Then we calculate the new headroom. That's the first connection, PCC. Then, use transfer coefficients. We calculate the impact of the connection on remote nodes using incremental limit. Then calculate the new headroom at all those nodes. Transfer them to new PCC or second PCC and the portion. So it's one step more than before. It sounds complicated, but it's really not. It's just, if you read the text, it's for assessing the second PCC, you need to be aware that the transfer coefficients from second PCC to the PCC is not the same as transfer coefficients from first PCC to the second. So you need to rerun your model to determine the transfer coefficients for the second PCC, the way you did for the first. So, in term, we have got the new connection 1 to the PCC1. Determine transfer coefficients from PCC1 to PCC2 and bars. Follow the rules, and I calculate the incremental limit and the limit, and then I calculate the total limit for the new connection. Now to deal with new connection 2 at PCC2. This is initial measured background at PCC2. The impact of connection 1. So my initial measured background at PCC2. Issue the limit to connection 1. Assessing new connection 2. Identify the bound at connection 2. So this is initial background at new connection 2. This is third incremental limit I issued to the new connection 1. My background now that at connection 2 is that much. They're the same. I carry the headroom, issue incremental, and change and total limit. The total limit now would be, this would be its background component, not this one. You may, this is overestimation. practically speaking, I have to be careful to say that, but practically speaking, there is no other practical way to deal with this.
So what happens when you get a site with two feeds at two separate points on the network?
That's it.
The site would have two separate limits.
If you want, I don't know.
You have one site, so take for instance 33 kV.
So small.
I have it going to there, NC2 and NC1 is my two main connections so that I get a secure feed to my site. Where are with the limits with that? How would you portion to the site? By like that?
Yeah. This is new connection 1. I issue the limit as this. Apportionment of the headroom. Now, once I issue the limit, I assume that the background rises to the total limit I've issued. Because allowing new connection 1 to do that. I don't know if he does or he will, but I have to assume because they are not yet part of the network. I assume he's going to do that. At this point, I assume the background has risen to total limit. The issue to this. However, the impact of this, I assume they are impacted only incrementally by issues of this guy. So I assume all backgrounds will, according to the incremental limit I issue to this through transfer coefficient. Yeah?
Yep.
Which is here. Sorry. This is no. So, new connection 1 is connected. The background this point. But now I have to estimate the impact of this guy on here. I know new connection 1 has allowance to you to cause range of harmonic level at this point according to the incremental limit I've given them. If they are going to do that, I know they are not. They must not exceed that. That's the limit. So this is what I'm going to do. I assume we're going to use that. This is ground. Initial. I'm going to add to that background the impact of the new connection 1. Transfer coefficient. So, background, our new connection 1 is connected. This background will rise to that background. The new background at network new connection 2. This is once I've got estimated the background, I calculate the headroom. And then portion the headroom like before and come up with different components of limits exactly like before.
But it's the same site, it's just it's got different feeds. So NC1 and NC2 are essentially from site 1, which is just the same customer, it's just he's wanting different from different connection points. So how do you portion it? connections, because in theory, if n minus 1 was to occur on the site, a loss of a unit transformer, then you flick to the other side. You go to NT2. If you lost NT2, you go to NT1. So where do you lie with the apportionment? Normally, half probably would come off NT1 and half would come off NT2. Maybe I'm explaining it quite.
No, to be honest.
Our customer has got 2 feeds from the system and can switch to either of them.
Yeah.
Then presumably the utility will either 2 impedance loci, 2 limits, or could give 1 impedance loci, 1 limit, one loci that will cover both connections.
Only the load will not change, it's only the feed to the load.
But it shouldn't be double counted. It's not 2. You're saying it's one connection here. It's not 2 parallel connections.
Yeah. Well, you said 2 power connections.
Yeah, but
you got 1 load. So
there wouldn't be 2 limits. It would be 1 customer.
In theory, you can still go to a different. You can shift the load, so it can all go from one all on one side to all on the other.
You've got 2 transformers of 50%. You're going to make 1 transformer with 100% if that occurred, but the load won't change, though, will it?
No.
The same.
Yeah, the harmonics.
Just the way you're feeding it.
No. But the harmonics would be less. You'd split the harmonics across normally in normal operation. But if you lose it, all harmonics would go either one way or the other way.
Mark, what you're saying is of the loci envelope. The impedance changes when you take the transformer out. Follow this rule for limit. It doesn't matter. You just pushing the headroom.
Right.
But your impedance loci will be a small 2 transformer or big 1 transformer. That's where it affects the calculation and your transfer coefficient.
Well, you do is you take the worst case scenario of
Exactly.
the worst harmonic distortion.
And
if that's the biggest or the 2 smallest, you just use the worst.
Exactly. That's part of the impedance loci. You need to consider different operational conditions.
Get yourself emergency gen. You ask for questions. It's your own fault.
Thank you very much. I've got, Vincent, I've got worked example, very simple worked example. I don't know if it helps. We've got 20 minutes. If you like, I can go quickly through them, just to show how it works.
Work.
Work, phase 3.
There's work. Example?
Yeah. So, I just assumed, actually, my colleagues applied this method for concurrent connection, actual connection in a small area in the southeast. And it's very well. And we wanted to apply G54 would be nightmare. In this worked example, assume a very simple 5-bus network, like say X, Y, A, B, C. On this model, I get the transfer coefficients. My first connection is to bus bar X. So transfer coefficients out model from X to Y to X to A, X to B, X to C. So the transfer coefficients to different bus bars from X. I did the measurement at different bus bars. These are the measurements of background at different bus bars.
Is that transfer coefficient the same at every harmonic order?
No.
Picked one harmonic, so
This is only,
Thank you.
this is one harmonic.
Wait, got it. Thank you.
For this particular harmonic under consideration, all is 1.4, I assume. The planning level is 2. Okay? It indicates probably fifth harmonic. Right. So, what is, first, I calculate the headroom at the connection point, X. Planning level minus the background in the table was 0.5 for box X. It gives me a headroom of 1.79. The headroom available at bus bar X I can play with. And transfer coefficients from X to Y is, sorry, the headroom is 0.71. 0.1 is the headroom of bar Y transferred to bus bar X. The bound at bus bar Y was 1. Yeah? And headroom at bus bar Y is the difference between the 2 and 1. When I consider the transfer coefficients to bring that headroom to bus bar X, I get only 0.7. 0.1 means if I inject enough current at bus bar X, I'm confused now. If I inject current to get 0.71 at bus bar X, that would be 1 at bus bar Y at bus bar Y. Yeah? Because my gain is 2. Now, applies to the same harmonic, to the other nodes, and this is the background. All buses transferred to bus bar X. Now, according to G55, I have to take the smallest. For incremental limit, I take the smallest, 0.4, which is bus bar B is my limiting node. My limiting substation is substation B. My K is a wind farm of 800 megawatts. I take K, and K of 0.4, my multiplier would be 0.53. Then I apply multiply 0.532 to the back, the smallest term. That is my limit for connection 1. Incremental limit for connection 1. I don't use any data from the customer. Then the total limit, I have my M by the at station X, where the connection is made. The headroom there was 1.79, and that's my total limit, 1.21. Any change is 0.5, which is basically this. That's total change. This total change includes incremental and includes magnification of the background. this tells the customer that its total effect should not exceed this. Now, then the customer can calculate the amount of the point of this that it's allowed to use for amplification. So this minus 0.2 gives that. This is the assumption that he's going to use all the incremental equipment. So the limit table would have the background, the incremental, and the limit. That's it. I think colleagues are laughing, smiling. It's easy. Concurrent connection at the same PCC. The connection is a 2000 MVA connection. That means that at point X, still point X. So K1, according to the curve, apportionment curve, N is 0.66. I assume that for the second connection, the background at for X has been to the total limit of the first connection. Room available, the available for the second connection is the total limit of the first minus the planning level. That's the new headroom. Then the procedure is the same. For B, I calculated the transferred head of B to the X bus bar. Yeah? That is still minimum. Just modify it with the incremental limit I issued to the first connection. That is the incremental limit for this next one. The first one was 800 MVA. Incremental of 0.21. Second one is incremental of 0.29. FPI G54, this is 0 for the next one. The next one still got something. There is a note in the document about transfer coefficients. The action of the first condition does not change the transfer coefficient. As I said earlier on, the change in self-impedance or self-impedance and the perceived change in transfer impedance are the same. So the coefficient does not change. However, if you have connection to somewhere else, piece of capacitor or pole or capacity bank, then the story changes. the limits for the second connection. Sorry, 0.9 was the headroom, so I apportioned 0.29 to be the limit for the second one, and the total would be the headroom, which is the total limit for the first one, plus the total change limit. That would be the total limit for the second one. At different nodes now.
You see the simple examples for us.
Transfer coefficients from y to x, y to a, y to b, units. And these are the transfer coefficients for x to y. X to assume that this changed. In reality, after connecting the first installation, these may change or may not. Sorry, just checking. When the connection is connected, calculate. These change. Test the same node as the connection. These won't change. You need to calculate this.
And to calculate this, do I need this information, or we just agree on a network?
Yes, exactly what you said. In order to calculate this, you need this user data. It doesn't exist because they haven't designed it. You have to agree with connection I, connection X. Okay, so that was clear question. Right. Impact of the first connection on the background. X. Background is assumed to rise up to the total limit issued to the first one. At outs, you transfer coefficients from X to other nodes. You transfer incremental limit issued to X to other nodes and negated with the background I showed before. That'd be new background. So the background for X, which is equal to the limit total for connection 1. And then using this equation, the transfer coefficients from X to Y, X to A, X to B, give the limit to a approved node related with the background. That would be the background at that node. This example is node Y, so background of node Y from increase to 1.22. The transfer coefficients between X and Y, and this is the incremental limit issued to X. We've got the impact, you calculate the, again, this is the same process, but for nodes, A, B, C. So all the backgrounds, all nodes are modified by the incremental. Again, headroom now is calculated at node Y and other nodes. Transfer to Y. So, for example, this one is headroom of node B transferred to Y. The rest is the same. You take the smallest of these, and apportion the local. So the headroom is 0.28, you apportion it, that would be incremental for connection Y. The total change, limit change, and then you add it to the modified background Y, the total limit for Y. And if the user wants, I'm sure they need that, resonance is calculated from this. That amount they have to play with the magnification of background. It will be the table, limit table, and that will be the end of the presentation. Example. Anything?
The complicated one.
Another hour, is it?
This was implemented in a spreadsheet. It's just once you have the transfer coefficient, spreadsheet calculation.
Any chance we could get a copy of the spreadsheet?
It's on your computer.
Oh, okay. Great. Just a second. All right. What we is I'll do a quick look at the next steps. I think everyone's answered their questions today, or their questions. Next step in the stakeholder engagement is we're hosting a second event in Glasgow on the 9th of April. So if you know anyone who is affected, that may be in the north part of the country, do feel free to share that event information with them. The consultation paper is available on the DCode site, and responses requested by the 19th of April. So just looking at the website quickly. You see the open consultations. It's the consultation open at the moment. You'll see stakeholder dissemination event information on the consultation. The package is available for download there as well. I've got the slides that I've uploaded to the website. I'll also upload the work examples and the spreadsheet as well for them to have a play, as well as distributing that in an email so everyone gets a copy of it.
ENE's website.
It's on the distribution code website, so decode.co.uk. No, sorry, decode.org.uk. But who's attended today, I should be sending around an email with the slides and up with it as well. So 5 o'clock on the midday, please have had a look through the consultation paper, and if there's any concerning elements or
you want to propose modifications to what has been proposed, then time to do it is by that date. Responses should go to decode@energynetworks.org, so the code administrator. So, someone have business or?
Just a quick question, ETR 122, when will that be available? Another question, because obviously it's a bit more the right.
Well, the background and the worked examples are in separate documents.
Yeah.
As an interpretation of EMC test reports and explanation of converter types. I'm not sure how much more was intended on that. I know you mentioned it today.
We handed to work on it and revise ETR 122. I don't think, well, at least we are not in a position to say exactly when. But it's shortly after the publication of this. Shortly, maybe from 1 month to 2 years.
A lot of what would be in it is already in the other documents, but there are still a few elements that aren't.
Not the material. Calculation and examples are there, but there are many other stuff that needs to be looked at and revised.
I'll see if I can look in and see if there's any programmed update to that and who's involved and what the timeline might be. And I'll provide that clarification. Okay. With that, we're finished for today. Thank you all for coming along, and I hope you found this session useful.